Hello class, today we're going to do chapter 6, specifically 6.1, and we are going to cover real numbers, order, and absolute value. Now, we're going to learn how to represent a number on a number line, identify a number as positive, negative, or zero, identify a number as belonging to one or more sets of numbers. Given two numbers, A and B, determine whether A equals B, A is less than B, or A is greater than B. And given a number A, we're going to determine its additive inverse and its absolute value, as well as interpret signed numbers in tables of economic and occupations data. Now, let's start with the sets of real numbers. We're going to start with the natural numbers. Those are just your counting numbers. 1, 2, 3, 4. Does not include 0. But the set 1, 2, 3, 4, all the positive numbers there, positive whole numbers, going on forever, is your set of natural numbers. Now your whole numbers include 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, continuing on forever. So let's look at a number line. A number line includes both negative and positive numbers. Okay, positive and negative numbers are called signed numbers. Okay, so you can see the number line here goes from -4 to +4. The lines here, the arrows on the end indicate that it continues forever. Here we're just using a number line that jumps by ones. Okay. All right, let's look at sets of real numbers. The set of numbers marked on the number line on the previous slide included positive and negative numbers and 0 is a part of a set of what we call integers. So negative numbers, 0, and positive numbers there. Those are your integers. Okay, so integers includes the set, that goes from all your negative whole numbers to all your positive whole numbers, including the number 0. All right. Numbers such as a half or -1 2/3 are not integers, they are rational numbers. Okay, so a rational number is x such that x is a quotient of two integers with denominator not equal to 0. That is the set of rational numbers. Okay, so the graph of a number is a point on the number line. A few numbers are graphed below. So like here, -1/2, that is a rational number. 2 2/3 is a rational number. The -2 would be an integer, but would also be a rational number. So numbers can belong to multiple sets here. Okay, not all numbers are rational. For example, the square root of 2 cannot be written as the quotient of two integers, so it is called irrational. Okay, irrational numbers are numbers x such that x is a number on the number line that is not rational. So if it's not rational, it's irrational. Okay, so here's kind of your set of your real numbers. Okay, real numbers include irrational numbers, rational numbers, but within the rational numbers you can have integers, and within integers you can have whole numbers, and within whole numbers you can have natural numbers. Okay, so a natural number can also a natural number is always a whole number, but a whole number is not always a rational number. An integer is always a rational number here, but might not always be a whole number, because there's certain whole numbers that are integers, but not all integers are going to be whole numbers. So you can kind of see how those sets are contained within each other. Okay, so let's identify elements of a set of numbers. So the list the numbers from the set -3, -1/2, 0, 1, 1.8, and the square root of 7. And we want to list the ones that are natural numbers, rational numbers, and real numbers. So the natural numbers, the only natural number we have here is 1, because you remember 0 is not included in the set of natural numbers. Rational numbers include -3, -1/2, 0, 1, and 1.8. The reason that the square root of 7 is not included in the rational numbers is it cannot be rewritten. Essentially, it can't be rewritten as a fraction. So I can't rewrite the square root of 7 as a number a over b. Okay, I can rewrite any of these other numbers as a fraction. I could rewrite -3 as -3 over 1. That would be a fraction. I could rewrite 1.8 as, say, 18 over 10. That would be a fraction, but I cannot rewrite the square root of 7 as a fraction. That is why it's not a rational number. Real numbers, though, all the numbers that are listed here are real numbers, every single one of them. Okay. Now, two real numbers may be compared or ordered using ideas of equality and inequality. Okay. The law of trichotomy states that for two numbers, A and B, one and only one of the following is true. Either A equals B, A is less than B, or A is greater than B. Okay. The symbol less than or equals to means less than or equals to. The statement is true if the equal to part or the less than part is true. So 5 is less than or equal to 7 is true, as is 5 is less than or equal to 5. That is also true. Both of these are true statements. Okay. As long as one of the two holds, the statement's true. The symbol greater than or equal to means is greater than or equal to. The statement is true if the equal to part or the greater part is true. They don't have to both be true. Just one or the other have to be true. Okay. Now let's look at additive inverses. For any real number x except 0, there is exactly one number on the number line that is the same distance from 0 as x, but on the opposite side of 0. For example, 3 and negative 3 are the same distance from 0, but on opposite sides. These numbers are additive inverses, negatives, or opposites of each other. Just different ways to say it. And if you think about it here, if you got your number line, okay, you got 0 in the middle, 1, 2, 3, negative 1, negative 2, negative 3. Like I said, they're both the same distance here from 0. So the only difference is they're different directions. Okay, so they're additive inverses. If you added them together, you would get 0 because 3 minus 3 is 0, or negative 3 plus 3 is 0. Okay, they're opposites of each other. They cancel each other out. All right. Let's look at the double negative rule here. Double negative rule kind of applies to this multiplication that's happening here. For any real number x, negative x is equal to x. So basically the negatives cancel out. That's the double negative rule. A lot of people struggle with this rule, but a negative and a negative is going to turn it back into a positive. So a negative times a negative is going to be a positive. Essentially what's happening here is you're doing negative 1 times negative x. Negative times the negative gives you the positive, which is why you still wind up with negative x. Okay, you can even think about it in an English manner. If you're not going to go, that means you're going to go, because the not and not cancel each other out. So it's essentially the same thing here in math. Okay. Absolute value. The absolute value of a real number can be defined as the distance between 0 and the number on the number line. The symbol for the absolute value of x is basically these two bars surrounding x. That is the absolute value, and it's read the absolute value of x. Okay, so if you see a number with two vertical bars surrounding it, it's wanting you to take the absolute value of that number. The absolute value of a number is never negative, it's always positive. Okay, so for any real number x, the absolute value of x is x if x is greater than or equal to 0, or is negative x if x is less than 0. Now this mathematical way of writing it confuses a lot of people here. Essentially, if the number is positive, it stays positive. If it's negative, it changes to positive. Okay, that's essentially all it's saying. So let's try some examples here. So A says the absolute value of 4. 4 is positive, so it's just going to stay positive. Absolute value of 4 is 4. But the absolute value of negative 2 will turn to a positive 2. Okay, and so let's pause here. So the absolute value of negative 2 turns to positive 2. Now, the absolute value of something is always going to be positive, but it doesn't mean that I can't do a negative function to it afterwards. So in C, I have negative absolute value of negative 3. Now the absolute value of negative 3 here is going to turn itself into a positive 3, okay, just with this part, okay, but you still have that negative sitting out front, so you just forced your way to turning it positive only for that negative out front to turn it back negative. So the negative absolute value of negative 3 is negative 3, okay, because you had the extra negative out front. Now D says 1 minus 8, and they want the absolute value of that. It works just like parentheses. So you need to do what's on the inside of the absolute value first, and then take the absolute value when you're done. So if I did 1 minus 8, that would give me negative 7. So I'd really be looking at the absolute value of negative 7 here. And the absolute value of negative 7 is 7. Okay, so do the inside work just like you would on parentheses first. Okay, now when we are looking at the amount of change without regard to whether the change is an increase, positive, or decrease, negative, use the absolute value of the number. So example here, it's really hot. It's really hot. Okay, so if you want to look at temperature, of course these temperatures are really cold, but right now it's really hot. So if I wanted to look at the average change in temperature here, okay, so it says given the temperature readings of the days below, which day had the greatest amount of change? I want to see the greatest amount of change. Doesn't say positive change or negative change, just the greatest amount of change. Okay, so on day 1, the morning temperature was 23 degrees Fahrenheit and the evening temperature was 42 degrees Fahrenheit. The average or the amount of change there is 19 degrees Fahrenheit. All they did was 42 minus 23. That's how they got the 19. Okay. Day 2, the AM temperature was 32 degrees Fahrenheit and the evening temperature here was 55 degrees Fahrenheit. So what they did there, they did 55 minus 32 and they got 23. Okay. But then on day 3, the morning temperature was 40 degrees Fahrenheit and the evening temperature was 13 degrees Fahrenheit. And if we keep the same order that we're doing here, it would actually be 13 minus 40, which gives you that negative 27. Now, we're not really concerned with the negatives here. We just want to see the greatest amount of change. Greatest amount of change. The greatest amount of change is day 3 because we're not looking to see whether it's negative or positive. We're essentially looking at the absolute value to see which one moved the furthest. We don't care which direction. So day 3 had the greatest change of 27 degrees. And that completes 6.1. If you have any questions, shoot me an email. Other than that, I look forward to seeing you on the next lecture.